to this lecture on an overview of machine learning. Before we dive into text classification, let's work on understanding the general machine learning process we're going to be using. The specific case of machine learning we're going to be conducting in this particular section of the course is known as supervised learning. So we're going to be focusing on that supervised learning process. Because different students have different backgrounds in math, we're going to be keeping the mathematics behind the machine learning algorithms on the lighter side. A great textbook on general machine learning, especially if you are interested in mathematics, is called An Introduction to Statistical Learning by Gareth James as a companion book. It's freely available online as a PDF, and it's released for free by the authors. You can simply Google search the title of the book to find the link. So again, just Google search ISLR or Introduction to Statistical Learning, and you'll be able to easily find this book for free online. So let's begin by answering the question, what is machine learning? Machine learning is a method of data analysis that automates analytical model building. Using algorithms that iteratively learn from data itself, machine learning allows computers to find hidden insights without being explicitly programmed where to look. So the machine learning algorithm on its own is going to figure out what patterns and what features are important. Now, what is machine learning actually used for? As you may already know, it's used across a variety of tasks and industries, anything from fraud detection to credit scoring, loan applications, or the things we're going to be focusing on, things like text sentiment analysis or email spam filtering. So this is just a small subset here of what machine learning applications can do for us. Now let's talk about supervised learning. Supervised learning algorithms are trained using labeled examples, and that's a key word there, labeled. So a labeled example is an example where the input and the desired output is known. For example, if you have a data point as a segment of text, it could have a categorical label, such as the text of an email being labeled as spam versus legitimate, or the text of a movie review being labeled as a positive movie review or a negative movie review. The learning algorithm, or machine learning algorithm, is going to receive a set of inputs along with the corresponding correct outputs. And the algorithm is going to learn by comparing its actual output with the correct outputs in order to find an error, and then it's going to modify the internal parameters of the machine learning algorithm accordingly to achieve the best results on its own, without you explicitly programming it what it should change. Supervised learning is commonly used in applications where historical data points predict likely future events, such as historical information of previous emails you've received that someone has labeled as legitimate or illegitimate or spam. That historical data can be used in order to provide a future spam filter for future emails. So let's talk about the supervised machine learning process. And this is probably the most fundamental thing to get out of this particular lecture. So we're going to go through all these steps individually. Now, the first step is to actually acquire your data. And there's many different ways to do this. In this particular course, the acquisition is pretty simple. We actually just provide the data for you. But depending on where you're actually working or what you're doing for your personal machine learning projects, you can acquire the data through a variety of sources. You can check out the resource links in this lecture for lots of free data sources. Or if you're working at a company, you can work internally to acquire data about your customers or even from things like physical sensors, etc. So we're going to assume then that you've acquired the data. Then the next step is to clean and format your data. And in particular, if you're working with text data for natural language processing, you'll have to perform things like vectorization on that data, which we're going to cover in the lecture Text Feature Extraction. But you're going to have to do things like remove missing data points from your data and then convert the raw text into numerical vectors that machine learning models can understand. So that's a whole process that we're really going to focus on another lecture in the future. But you've acquired the data and then you've cleaned and formatted your data. Then once you have the clean and formatted data, you're going to split the data into training data or a training set and then test data or a test set. And then what you're going to do is on the training data, you're going to grab your machine learning model and have it learn or train off that training data. And that's also known as fitting the model to the training data. So the machine learning model is going to attempt to learn as best it can the different application that you're looking for. So if you're trying to build an email spam filter, right now it's working on that training set of data. and the training set of data is commonly about 70% of the total data. So you're training your model, and now the model has learned on your training data. Now it's time to evaluate your model's performance. And for evaluation, it makes sense to use data that the model has never seen before. That way you're not cheating. That's why we have the separate test data set, around 30% of our data. So we take the model we just trained on, and then we test it against that test data set. And then we can evaluate how well the model actually performed using different evaluation metrics. And we're going to talk about evaluation metrics in a future lecture in this section. So after evaluating our model, we can decide to improve the model, maybe edit some parameters of the original machine learning algorithm. So we can go back to the model and training and building phase, adjust some parameters, and essentially repeat this process until we're satisfied with our model's performance, and then we can deploy the model. So for text classification and recognition, this is a really common and widely applicable use of machine learning. And later on in this section of the course, we're going to be learning about the scikit-learn library in order to use Python to conduct machine learning text classification. Now let's take a quick moment to focus on that idea of the train-test split that I just mentioned and that we just saw occur, and we're going to learn a few key terms. So let's imagine a full data set of what is known as ham versus spam text messages. And ham is just another word for legit or correct text messages, basically the opposite of spam. So we're going to imagine a full data set, and our data set is going to look something like this. Notice that we have a label and the actual raw text message. So you can see the one in the middle there, that's a spam text message offering some sort of bogus free entry in some weekly competition. The other text messages are ham or legitimate text messages. So our idea here is that we're going to build a machine learning model that can detect, given a new text message, whether or not something is ham or spam. Now before the split, we're going to have labels and features. And in this case, the label is again the historical label ham or spam. So that means that someone manually had to go in and read the message and then label it as a legitimate message or a spam message. So that's a key part of supervised learning, is that you have to have historical labeled data. And often labeling your data is a manual process. Now, in this course, you're not going to have to label any data. We provide labeled data for you. So we have what's known as the Y label and then X features. Features is the actual data points that you're going to use to predict the Y label. And the reason we have Y and X is because in linear algebra notation, the way the mathematics work out, you usually have an X matrix of features and a Y label. And often you'll see Y lowercased. So this is right before the split. We still have labels and features. We haven't actually done a train test split yet. What we want to do is probably take about 70% of these points, both the labels and the corresponding messages, and save those for the training data, and then take the other 30% and have that be our test data. So once we have our Y labels and X features, before we fit the model, we'll split the data. So we're going to take this data and we're going to split it. So this is a really small example of a data set, just 5 points, but we've already shown that we're splitting it. So again, notice here's our total data, and we're splitting it into a test set and a training set. Remember that we still have our Y label and X features. So we just split the data, and we have now our test set and our training set. And now what we can do is we can individually label the subsets of Y's and X. So what you're going to see when you do the actual train test split with Python and scikit-learn is 4 outputs. You have your Y labels, your Y test and Y train, and then you have your X features for the test set and your X features for the training set. So don't be confused when you run the train test split and see 4 outputs: Y test, Y train, X train. All it is the data set being split into 2 pieces, your test set and your training set, and then those 2 pieces being split along the Y labels and X features. So that's all that is those 4 terms mean. So again, we have those 4 components, and you're going to see these components often throughout the course. So these 4 components are simply the result of the train test split groups being separated between features and labels. Coming up next, we're going to continue to understand the classification process in more detail, and importantly, metrics in order to evaluate a classification process. We'll see you at the next lecture.